In this clip, we'll look at how to find the mean for weighted data. So what is weighted data anyways? Well, if you've been in high school, you see it pretty much every day. You know those categories you get marked in, like knowledge and communication and application? Well, each one of those has what's called a weight. Let's do an example problem and maybe you'll see what I'm talking about. The term marks in a math class are divided as follows. Knowledge and understanding is 25% of the mark, and then application is 15% of the mark. And we have problem solving for 20% of the mark, and communication is 10%. And the question is two parts. In A, if a student's marks in these categories are 78, 75, 80, and 85, respectively, determine her mark, or her term mark. And then in B, what mark will she need on her final exam in order to finish the course with a mark of 82%? All right, let's tackle A first, where we're going to have to find the mean or the average to get her term mark. In order to find her term mark, I have to find the weighted mean. Weighted because each category is worth something different. So the way this changes our normal formula is we're going to multiply the weight by her mark for each category. So let me show you what I mean. The first category, knowledge and understanding, is 25%. As a decimal, I know that 25% is 0.25. Then I'm going to multiply that weight by her mark in that category, which is given as 78. Then I will add the next category, which is 0.15. That's the weight for the application section, and her mark in that category was 75. So I'll multiply that by 75. And we'll continue doing that. So finally, we end up with a line that looks like this, where we have her scores in each category, and each time it's multiplied by the weight in that category. Then, just like any mean equation, we're going to divide by the total. Now, in this case, the total is all of these added together, or these numbers right here, the decimals. 0.25 plus 0.15 plus, what's next, 0.20, and last plus 0.10. So this is looking pretty big and chaotic, so I'm going to just simplify it on the next line. I'm going to go ahead and use my calculator, but I'll skip that step and just show you what I got for the top and for the bottom. So for the top, I got 55.25, and then the bottom, we added all these decimals together, and we get 0.70. Now, what do you think is significant about this 0.70? Well, if we added up all these categories, it looks like the term marks are 70% of the course, which must mean that the final exam is going to be worth 30% or 0.3. So try and remember that tip for the next step in part B. Let's go ahead and just find our final answer for part A. Punching this number divided by this number into the calculator, let me know that her term mark was 78.9. Not so bad for a math class. And now that I know what she has going into the exam, let's move on to part B. Part B asks, what mark will she need on the final exam in order to finish the course with a mark of 82%? So we know she's going into the exam with 78.9, but we don't know what she needs to get on the exam. So we have an unknown. And unknowns, well, that's what variables are for. Let's make a variable called e for her exam mark, and we'll set up a little equation. We know that the term marks are worth 70%, or 0.70 in decimal form. And we know that in the term she got 78.9. Now, since all course marks must be out of 100, or 100%, that means that the exam must be worth 30%. 70 and 30 make 100. But we don't know what she needs to get on the exam, so that's where the e variable comes in. And this entire equation represents her mark in the course overall after the exam and after her term work. So she would like to get an 82. And that goes at the end. So now we have to just isolate for this e. I'm just going to move some pieces of this equation around so that I have E by itself. I'm going to keep that 82 the way it was on that right side of the equal sign. This whole piece is going to move to the other side, so I'm going to subtract it since it was being added in the first place. And finally, there was a 0.3 multiplying the E, so it goes over to the other side as division. From here, it's just a matter of punching in whatever I see here into my calculator. I'm just going to give E equals, and then I'll skip the calculator work because it's pretty straightforward, but you should get a final answer about 89. So she's going to have to do pretty well on her exam. So if she studies really hard and fortunately ends up with an 89 on her exam, it'll boost her mark up from a 78.9 to an 82, which is what she was after. So there's an example of how you would use weighted data and find the mean in everyday life. It comes up all the time in school marks. So let's get you to try a problem now using the same steps. Let's give you a chemistry class. The term marks in a chemistry class are divided as follows. Knowledge and understanding is 30%. Application counts for 20%. Problem solving counts for 15%. And finally, communication counts for another 15%. And then in A it asks, if a student's marks in these categories are 72, 80, 68, and 89 respectively, determine his term mark. And then in B, what mark will he need on the final exam in order to finish the course with a mark of 80%? All right, so try that out, A and B, using the steps that I showed you right here for finding a weighted mean. I'll post a solution when you're ready. Well, just before he writes his exam, he's going into the exam with a mark of 76.4. And if he wants an 80, he's going to need to get 94.4 on the exam. So I hope he starts studying.